Alright, John, and we're back and we're talking about how many different ways we can make a 4-digit even number. And like it's pretty much the same thing that we just did before. An even number is determined by the last digit has to be an even number. So this time I want you to take a look at all the numbers that we have as our possibilities. And we actually have 3 total options first that we could put here to make this an even number. So we have 3 different options we could place right there. But no matter which one I choose, let's just say I chose the 4, it doesn't really matter. Now, coming back up to the front, how many numbers do I have left over now? I have only 3 numbers left. And then say I chose that 2, now I'm down to 2 options left. And then finally I'm only left with 1 option. So that is clearly different, even numbers versus odd numbers. So 3 times 2 times 1 times 3 is 18 different numbers. How many 4-digit numbers that are greater than 4,000? Well, how do you know that a number is greater than 4,000? That first digit right there has to be bigger than 4. So, greater than 4,000. Let me see. If I put a 2 in the first decimal, so actually, what is changing this number right now is the first digit, not the last digit, like the last ones. So this one is the important digit that we need to look at. Clearly, we can't put a 2 in there, because then that would turn into a 2,000, which is less than a 4,000. If I put a 4 in there, it's okay, because all the other numbers would be like 267 or 672 or something like that. That's clearly bigger than 4. So I have 3 options that I could put in the first place, which is right here. And then, after I'm done with one of those, after I chose, say, the 4, I now still have 3 more options left. Because after one of the big numbers put right there, it doesn't matter which one of the 2, 6, or 7 that we choose. So I'm left with 2, or 3, then 2, and then 1. So this time we have 3 times 3 times 2 times 1, which is 18 again. And then the last one, 4-digit, odd number greater than 4. Oh boy. Or I'm sorry, greater than 4,000. So this time it's an odd number. So clearly, what number do we have to put in that last digit? If it's an odd number, it has to end in an odd number. So we only have 1 option, and that has to be the 7. So there's only 1 option that we could put here. It also has to be greater than 4,000. So we cannot put that 2 in the first digit, but we can use the 4 or we can use the 6. So there's 2 different options that we can put here. After one of those is gone, we're only left with 2 more options here, and then finally 1 option there. So 2 times 2 times 1 times 1 is just 4. There's only 4 total numbers that we could put there. Alrighty. Identify them. We could identify them. We have only 2, 4, 6, and 7. 2, 4, 6, and 7. And all of these numbers, I'm going to list out the 4 options that we have. All of these numbers have to end in a 7 because they're going to be odd. And then they have to be greater than 4,000. So there's 2 options up front. So it could be a 4, or it could be a 6, or it could be a 4, or it could be a 6. Now, if I chose the 4 and the 7 is gone, that means that, or actually, it's probably easier to do it like this. It could be a 4, or it could be a 6. If I chose the 4 and the 7, I'm left with a 2 and a 6, or a 6 and a 2. If I chose the 4 or the 6 and the 7, then I'm left with a 2 and a 4, or a 4 and a 2. Now, none of the questions on the test are ever going to ask you to do that, but it is kind of cool to see that this crazy method that we have going on up here actually, makes sense, and we really only do have 4 total options. So it's not like we're just making this stuff up. So hopefully those questions kind of helped you out just a little bit for the homework that you're going to have to do. I actually still have one more question that I want to talk to you about. And that's a lot of the questions that you're going to see in your green book if you're practicing, or on practice Regents exams, are going to be something like this. How many different ways can the letters in the word Tennessee be arranged? And, you know, sometimes they're not going to use Tennessee. Sometimes they'll use a different word, like Vermont. Or maybe they're going to use Mississippi. But you're going to see questions like this a lot. And the reason why they choose words like that is because you see letters repeating. And they're going to say, if I can only use the letters in this word, how many different ways can I rearrange them? Okay. So that means if there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's 9 different letters that I have. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it doesn't say that they have to be arranged in a certain order. It just said how many ways can I rearrange them. So for this first spot right here, I have a total of 9 options. Then I'm down to 8 options, then 7, 6, 5, 4, 3, 2, 1. And we just talked about an easier way to write this. We don't have to write out all these numbers every single time. We could just write this as 9 factorial. Except for what you should be thinking to yourself now is, wait a second, I have letters that are repeating. So just because I'm rearranging that word or rearranging the letters in that word doesn't mean that I'm getting like unique different rearrangements every single time. Because what if one time the E lands here and then another time that E lands here? You know what I mean? So this isn't necessarily the total number of unique arrangements that I could possibly make. So what you need to do is divide out those arrangements that are going to make it not unique. So what you need to do is go through and say, all right, I have 1, 2, 3, 4 E's. So I need to take that into consideration. I need to divide out those 4 E's. Then what you need to do is go back and say, wait a second, I have 2 N's. That's a problem. So let's divide out those 2 N's. And then, oh my gosh, I also have 2 S's. So I need to take that into consideration as well. So I need to divide out all of those numbers. But once you do that, this question becomes really easy because you can just type it into your calculator. So 9 factorial divided by 4 factorial times 2 factorial times another 2 factorial. And my mom is calling me at the moment, so oh my gosh, what did I just do? Something really confusing and bad. So let me do this one more time. 9 factorial divided by 4 factorial. I wish that there was an easier way of doing this. Times 2 factorial times another 2 factorial. And then hit enter, and apparently there are 3,780 different ways that you could rearrange the letters in the word Tennessee, which is actually pretty cool. And I'll be right back though. Then the next one, if you take a look at the word Vermont, the first thing that you need to do, if you want to set it up just like what we just did for the word Tennessee, you need to think about how many total letters we have in this word. So you have 1, 2, 3, 4, 5, 6, 7. So instead of writing out all the spaces and then just doing 7, 6, 5, 4, 3, 2, 1, you could just write 7 factorial on the top. Divided by how many letters in that word repeat? Well, V doesn't repeat, E doesn't repeat, R. It looks like none of the letters in the word Vermont actually repeat itself. So this is actually really easy because we don't have to divide out anything. Instead, all I need to do is figure out what 7 factorial is. And I could do that by multiplying all those numbers, but it's really annoying, so let's just use our calculator. That's 5,040, which is pretty easy. Excuse me. And then the last one that we're going to do is the word Mississippi. Hopefully by now you're beginning to see a trend. Let's count how many letters that we see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I see 11 total words. So on the top, I'm going to do 11 factorial. Clearly for this one, there are letters that repeat. So let's take a look at what those are. I see 1, 2, 3, 4 I's. I see 1, 2, 3, 4 S's. And then the final one, I see 2 P's. So you need to take those into consideration. Say, hey, you know what, those are pretty much going to screw up my unique arrangements of this word, so I need to divide those out. So we're going to do 11 factorial divided by 4 factorial times another 4 factorial times 2 factorial. And hit enter. Whoa, we have 34,650 different arrangements that we can do of that word, despite the fact that a lot of the letters repeat, which is actually pretty cool. Obviously, when you're rearranging these letters, you're not going to get out like a word that makes sense every single time, but it is pretty cool to think that there's that many different ways that you could arrange just those letters. Okay? Alright, I am going to stop right here and then start another video, and we're going to talk about the binomial theorem.